Hello, welcome to another online lecture on distributed networks. In today's lesson, we are going to be discussing about access control lists. In the previous lessons, we have talked about routers and switches and the components and what do they do when it comes to directing traffic in a network. But when we think about such devices, particularly a router for example, all that a router does is redirecting traffic. So it is routing traffic from one network to the other. That's all it does. By default, a router does not filter traffic. That is, there's no form of control. There's no form of in terms of who can access what, can this network be in access from someone else. So there's no such controls happening in a router. By default, that is not happening. This is where we get to use what are called access control lists. So access control lists are basically a set of rules that we can apply across these interfaces, the router interfaces, and say what type of traffic or what packets will be allowed. So all the network packets will be evaluated, and based on the rules that are there in that particular device, it will make a determination as to whether that packet will be allowed to go through. So the basic idea of access control list is that. So when we have a number of networks and they are interconnected, we can have these rules that say whether a packet will be allowed or not. So for example, if we have, say, some devices connected from S1 and then some devices connected to S2, so then we can have certain control in terms of no video to S1, no access to S2 for S1. So likewise, we can have some rules here that would say what are the type of accesses that will be allowed and what are the type of accesses that will not be allowed. So that is the very basic idea of access control lists. So in addition to doing our network routing, we will do some additional controls in terms of what is allowed and what is denied based on some of the rules that we will have in these devices. So when we talk about access control lists, they are basically a sequential list of permit or deny statements. We will call each of these statements as access control entries or ACEs. So we will have a list of access control entries, and each of the access control entry would say what is allowed or what is denied, what is permitted or what is denied. So ACEs, we may call them as access control statements sometimes, and in a typical IPv4 ACE, we would use the concept of wildcard masks. So again, we have looked at wildcard masks previously as well. They are sort of the inverse of, not inverse, but slightly different, but somewhat similar to subnet masks. So that is something that we have discussed previously. So ACs will also may use wildcard masks there. Then another important thing that we need to remember when we talk about access control list is that these rules have to be specified one access control list per protocol. That is, if we are using IPv4 and IPv6, then we should have access control list for both IPv4 and also for IPv6. Then one ACL per direction. So when we talk about this device, traffic coming in and traffic going out, for both of these paths, we will have to have access control list. And one per interface. If our router has a number of interfaces, say a number of gigabit Ethernet interfaces. Each of those interfaces will have their own access control list. So when we think about a router on its own, we will have the gigabit Ethernet interface, for example. Then that gigabit Ethernet interface can carry traffic on both directions, so it can carry incoming traffic and outgoing traffic. Then also it can carry traffic for IPv4 and IPv6. So now we will have access control list for all of these different scenarios depending on how we have configured our network. So if we have, say, two interfaces and two protocols, then there the router will have 8 separate access control lists. So when we think about an access control list and what it does or what are the sort of things it can do, we will look at that with an example. So we will look at few things, that is, say, from which networks or from where it is coming. So we can have some rules about that, from whether it is coming from network A or network B, and then we can ask what service or what port it is trying to access, whether it is asking for port 80 or not, then ask each of those cases, and then we can have different allow and deny statements for those cases. So in this case, what we have is we have allowed web traffic from network A, but we have denied all other services for network A users. If it is for port 80, it is allowed, everything else is denied. But whereas for network B, port 80 is denied, everything else is allowed. So in these two different networks, we are allowing and denying two different things. So that is sort of essentially what we can do with access control lists. And then when it comes to access control lists, particularly IPv4 access control lists, we will have two different types of access control list. One is called a standard access control list, and the other one is called a extended access control list. In terms of the standard access control list, it only considers the source address. So that is from where the packet is coming. It only considers that, the source address from where the packet is coming. So a particular access control list number 10, will permit any packet that is coming from this particular network or that particular source address. Any source address that is matching to that network will be permitted. So the standard access control list, we will normally place them as close to the source as possible, because we are making these determinations based on the source information. So rather, if we will place it rather close to the destination as possible, because we are filtering based on the sources. So any number of sources can come to a particular destination, and destination can make a determination of as to whether allow or not. When it comes to extended access control list, with extended access control list, we are now not only relying on the source address as we had with standard ACLs. With extended, we are also looking at protocol types, protocol numbers, so that is looking at whether it is IP, ICMP, UDP, TCP. We are also looking at source and destination IP addresses, so not only just the source, but also source and destination IP addresses, but also looking at the services or the ports that we are trying to access. So which destination source and both destination ports we will consider. So here, for example, an access controller entry could be stating TCP, the network identifier, then also we can specify services and ports there. These extended ACLs can easily be placed closer to the source itself because we already know what the destination is. With an extended ACL, from the beginning itself, we know the destination, so we can plan ahead and limit the traffic before it leaves to the next part of the network. And that is one of the main advantages that we will have with extended ACL, that is, unwanted traffic can be blocked closer to the source, whereas with standard ACL, those blocking can only happen closer to the destination, because up until the destination we will not know whether what type of decision making has to be made, because we are only relying on the source information there. Whereas with extended, because we have source and destination information, we can make those determinations closer to the source. Then when it comes to actually creating the access control lists, we can create them using two ways, both standard and extended access control list. We can create them using either a number or a name. So we call them as numbered ACLs or named ACLs. And a numbered ACL is basically we assign a number for a particular ACL. So we can have there are certain numbers that are allocated as standard IP ACLs and some as extended IP ACLs. And then in terms of named ACL, it is basically any sort of alphanumeric characters we can have, and only thing is we cannot have spaces and punctuations. But other than that, it is again another way of identifying the access control list. So that list of rules will be identified either using a number saying ACL 10, something like that, or ACL outbound, something like that, a name or a number. So if we look at standard ACL first, standard ACL is normally configured to block all traffic. In this case, for example, we want to block all traffic from this network going to this network. So that is all traffic originating from here 10.0 going to 30.0. So that is what we are trying to control. So that standard ACL, because it should be applied closer to the destination, the place where we will apply that is here. So where it is leading to 30.0 network, that is where we will apply the rule saying traffic from 10.0 should be allowed in, because closer to there we can say if the traffic is coming from 10.0, it is allowed there. Say here in this case, if we have a rule that is about blocking, so that is we are filtering out traffic from 10.0 to 30.0. So that blocking, if we do it here, then that's fine. Up to in this path, if we block anything that is coming from 10.0, so that is only affecting S3 or this 10.30.0 network. If you put that rule anywhere else, here or here, what that would mean is, say for example, if you put the rule here, that would make any traffic coming from 10.0 also not going to 31.0. So we only want to block it to 30.0, but if we put the rule here, it would also block it for 31.0. So that is why we have to put the rules closer to the destination itself. Say if we put it more closer to the source, for example, if we put it somewhere here, then that would mean it is going to filter out for all the traffic. So again, when we are using standard ACL, we will put the rules closer to the destination. So that is the main aspect of using standard ACL. But the only other main point about standard ACL is we will only have information about source, where the packet has originated. We only have the information about the source network. That's all we have. So if we look at the syntax for standard ACL, it is ACL list and an ACL number, then the rule of whether it is a permit or a deny, or we can also have remark. Remarks are like comments. So it is like a comment you would have in a piece of code, and then we identify the source and the source wildcard address there. So here in this example, you can see, say, we have an access list and it is 10. The access list number is 10. It is permit. It is from 10.0 network with a wildcard mask .255. So here what we have is this rule will permit all addresses from this network. It will allow all the networks from coming through into that as part of that ACL rule. It will allow all the network traffic from that network addresses. Then if you want to remove that access control list, we will use the no access list command with the same identifier for the access list, here access list 10. So we will use no access list 10 to remove that access list. Say if you want to use the remark command, this is how we may use it. We could use it is like a command, comment. So we will do it like access list 10 remark permit host from, say, the 10.0 LAN. Then we will add the rule saying access list 10 permit, that permit rule. Then now if we go to show running configuration and access list, here we will be able to see that comment and the rule. So this is a way to help us identify what a particular access list meant, a particular statement in that access list meant. Because when you have a lot of networks and a lot of access list entries, these type of remarks will help us identify why a particular entry is there and what we are trying to do with that. So once we have created an access list, then we will have to assign or allocate that access list to an interface with a direction. Because we have already said access lists are about which direction of travel or which direction of information transfer they are trying to control, whether it is incoming or outgoing, and also which specific interface. It is not applied all across the router, it is applied only for a specific interface. So again, what we will have to do is we will have to go into interface configuration. Say for example, if we are configuring serial 0 interface here, so we will first create an access list. So we will, whatever the rule that we want to have, permit 10.0 as the access list. Then we will go into configuring the interface, and within the interface configuration we will use the IP access group command and then give the access list name or the number, and also specify whether it is in the in or out direction. So in this case, IP access group 1 outbound. Then again, if you want to remove that entry from that particular interface, we will use the no access list and no IP access group commands to remove those entries. With regards to named ACLs, they are not so different, except for the difference being we will use a name here. So instead of having a number here, what we will have is a name. Say for example, we can create something like IP access list standard no access. So that is creating a standard access list with the name no access. And then inside that access list, we will have the commands for deny host this, permit any, exit, and then we'll go into the interface and associate that with the interface. So the configurations are slightly different, but conceptually it is still the same, because we have a way to starting a list. Then within the list, we will go and put our command. So we will put deny and permits, whatever that we want to have, and then we will go and associate that with the interface. So similarly, we can have permit permits or denies or even remarks we can have here, similar to how we had earlier. So once we have created these access lists, we can simply go into, say, show IP interface command and see if there are any access list associated with that. So that will show whether there are any outbound access list or whether there are any inbound access lists. Then if you want to see the specific access list, for example, we can go and see the access lists and list out the specific access list and their comments and commands and all these rules that are there as part of those access lists. We can view that there as well. So with standard access list, as we said, the main differentiation when comparing with extended is standard access list only consider the source IP address. So they only check with the source IP address, and that is the only information that is checked with the access rules. Whereas with extended ACLs, what we have is we will be able to check additional things. We will be able to check source address, we will be able to check destination address, we will be able to check the protocols and the port numbers. So extended ACLs will consider a lot more information compared to standard ACLs. And again, extended ACLs can also be numbered within the given ranges, and also they can also be named. So when it comes to using ACLs, we are most likely to use extended ACLs than standard ACLs because they give us a lot more control, a lot more fine control, so we can control based on all these different factors. So using extended ACLs would be much more advantageous, and we would prefer to do that if that is necessary. Then another thing to remember in terms of configuring extended ACLs is that we will configure them closer to the source itself, because we already know everything about where it is going, all the destination information. So at this case, even if we are filtering out at the source, it doesn't matter because we will only filter out to a particular destination. We are not going to block out everything else. Say for example, if you want to block 30.0, we can block 30.0 here, and it will only block 30.0 destination addresses, and 31.0 will still be allowed through the network. Whereas in standard, it was not possible because we didn't know the destination in the rule. So here we know the destination in the rule. We can already control that here in extended ACL. So this gives us the advantage that unnecessary packets are no longer going into the extended network. They are blocked as close as possible to the source. So it in a way also helps eliminate undesirable or unnecessary traffic going into the network, which is actually a good point in terms of utilization of the overall network infrastructure. So if we look at extended ACLs, for example, the structure of extended ACLs, we can use them with either port numbers. For example, we can say 23, 21, 20 if we know the port numbers, or we can use for well-known applications, we can also use the name like Telnet, FTP or FTP data. So in Cisco iOS, you can use the question mark command to find what are the supported port, well-known port names. But other than that, if you know a particular port, you can say, for example, you can put 80 here. So that is up to you. So if we look at the overall syntax of extended ACLs, we will have access list, a numbered extended ACL, we will have access list and the ACL number. Then we can have either permit, deny, or remarks. Then we will give the protocol. So that would make, say, whether it is TCP, UDP, whatever. Then we will have the source, wildcard, the source address, the source wildcard. We can have operators, port numbers, port names, destinations, and then again destination operator port names. So for example, what we have in this example is we have access list 103, a permit. For TCP is the protocol, and then source is this network with the source wildcard being this, and then the operator being any, then the destination and the destination port number are identified by this. So in 103, ACL 103, it allows requests that are coming to port 80. So in destination, it should be port 80 or port 443, whereas the source port can be anything. And the destination address doesn't matter there. It's only checking for the source address and the destination port. Whereas 104, it is allowing establish HTTP reply. So if an HTTP connection is already established so the source can be anything, and this particular, the destination can be based on this. So it is about the replies. So if a web server is receiving a request and the web server needs to send back replies, so this is about that. So this particular established parameter that we will have in extended ACL, we will use that in a way to allow responses to traffic that has already come. Say for example, if a network traffic came from 10.0 and then because the 10.0 requests were already allowed, so now responses to 10.0 are also allowed, but it should be only as a reply to a previously received request. So that is our response. So that is what that is how we would configure a extended IPv4 ACL. So then when it comes to assigning them to a particular interface, it is fairly similar. So we create the list, we give the rules there, then we go into the interface and we specify 103 as the incoming rule and 104 as the outgoing rule. So we will again configure that based on those parameters. So for example, in this example, what we are configuring is we are configuring an FTP traffic, or rather we want to, if FTP traffic is going from say 11.0 to 10.0, we want to deny FTP traffic in that direction, but we want to allow other traffic. So here we will have a deny statement with the source network as well as the destination network, and also specifying that is FTP. So again we have deny, we have the source network, the destination network, and then the FTP data protocol. So we want to block both of those. Then normally, if you want to allow anything else, we'll also have another rule saying permit IP protocol, any source and any destination. So anything that doesn't get blocked by these deny statements will be allowed with the permit statement, because when these access rules are processed, they are processed one after the other. If there is a deny, then they are already denied. If they are not matching with these deny statements, then they will match with the permit statement, and then they will be permitted. Then they can assign that access list to the interface and get it configured like that. So then when it comes to named ACLs, extended named ACLs, again, the main point here is we will have the names identifying the ACLs instead of the numbers. And say, for example, the surfing is the one that is now going to allow access to 80 and 443. So this is the one that is going to allow the outbound traffic, permitting the outbound traffic going to web servers. And the browsing is the list that is going to allow return traffic, return HTTP traffic that is going to come as response to the allowed browse surfing traffic. So we will go and create IP access list extended surfing, and in that list we will allow this network to 80, this network to 443, and similarly we will create a browsing list. We will again use the established parameter to allow the responses, and then we'll go into the interface and assign the access groups, both the surfing as the inbound and browsing as the outbound. So once we have configured these, we can use the commands such as show IP interface, show access list commands to see what are the configured access lists and which access lists are assigned to which interfaces. So that's the two things that we'll have to check. So we'll have to first check what are the access lists and what are the specific rules in each of those access lists. Then we can go and check the interfaces and see which of those access lists are now actually assigned to which of the interfaces. So because these two things will have to be checked to see if things are configured correctly. So now once we have configured a set of ACLs, set of entries for ACLs, one of the things that we will have to do is we'll have to make changes. So obviously networks may change, the requirements of the networks may change, new things may have to be allowed things have to be denied, so there will be changes. Now there are two ways we can go about doing these changes. One of the easiest ways is we can go into show access list and get all the rules that are there. We can copy them into a text file. We do all the modifications in that, go and remove the whole access list using the no access list command and create the new access list with the modified configurations. Or the second option that we can have is using what is called using the sequence number. So we can use the sequence numbers that are there within the access list. So for example, within a named access list, we can go into the access list itself and then we can say we want to remove the entry 10. So that will remove this entry. And then we will create a new entry 10 with that. So with the extended access list, we can have that option as well. We can either use the text commands or text editor and edit them and reconfigure, or we can use the sequence numbers to delete some and add some again. And particularly the sequence number is what we would use to reorganize commands as well. Say for example, if you want to process one above the other, or sequence them, order them, we will use these sequence numbers to do that as well. Now let's look at how things are different with IPv6 access control lists. What we have discussed so far is mainly for IPv4. Now we will look at IPv6. In many ways, IPv6 ACLs are fairly similar to IPv4, but the main difference being in IPv4 we had standard and extended, and also we had numbered and named ACLs, whereas in IPv6 we only have named and also something similar to extended. So there's no standard and there's no numbered option there, only something named and also something similar to extended, where we have all the information there. So only sort of limitation, particularly in Cisco devices, for example, is that we cannot use the same name for IPv4 and IPv6 ACLs, but other than that, we can use any names as we would use with IPv4 ACLs. So when it comes to IPv6 ACLs, there are sort of three main differences that we can see. The first one is the command that we will use to apply IPv6 ACLs is IPv6 traffic filter. So the command is slightly different. The main command that we would use to apply these ACLs, it is slightly different. And in IPv6 ACLs, we don't use any concept of wildcard mask, but instead we will use the prefix length to indicate the source and destination, but which part of the source or destination address should be matched. And in IPv6 ACL, we would add two implicit permit statements at the end of the list to say which are the ones that are allowed or denied. So we will add two permit statements, implicit permit statements at the end of the list. This particular set of statements are there for the things like ICMP, neighbor discovery, neighbor solicitation. Some of these we may have discussed in some previous courses as well. So that is what we would have in IPv6 ACL there. Now let's look at some common issues that you may come across when you are configuring ACLs. To understand if what could be wrong in an ACL or in a configuring of an ACL, it is good to understand how ACLs will be processed. When it comes to, say, an outbound ACL, it would be operating in a particular manner. That is, any sort of information or packet that would match with the ACL statement. If there is a match, the rest of the statements are skipped. If the packet is permitted or denied, as per it is matched with the statement. If the packet statement doesn't match with a particular packet header doesn't match with a particular statement, then it is tested against the next statement until it is matched with a particular statement. Then it is considered based on that particular statement. And at the end of every ACL, we should always have an implicit deny statement so that everything else will be denied. So in a typical ACL, we should have at least one permit statement. Otherwise, all the traffic will be blocked because we will have an implicit deny statement at the very end. When we think about the outbound ACLs, again, a packet that is going out after the routing is done, the router will check if there is an outbound ACL attached to the outbound interface. and then again the testing will be done in a similar manner with the ACEs, and if they are based on those tests, the packet will be permitted or denied. But the main point here is we will go through the statements one after the other. If there is a match, then that will be considered whether permit or deny. If it is not a match, we will go to the next statement, and ideally at the very end of the list of statements we will have a implicit deny, so everything else can be blocked. So when a packet comes to a router interface, so when it is incoming to a router interface, the router will go and check whether the destination, if there's any match for the layer 2 address, then the frame is accepted. Then it will go into the ACL level and check the inbound interface. If there's an ACL, then it will check based on that permit or denied. Then it will go into, if it is permitted, then it will go into routing point, and then the routing aspects happen. Then after that, if it is going to go to outgoing interface, then that can also happen there. And then at the outgoing interface, again, if there is an ACL, then again the ACs will be tested again. If there is a match based on permit or denied, then again if it is permitted, the packet will be further forwarded to the next destination there from the router. So the main sort of difference that we would see is, like with standard ACLs, they are only going to check the source IPv4 addresses. So that is the only thing that is going to check in a standard ACL. So that is the one that will be tested for whether it is accepted or rejected. So that is the only thing that will be considered there. With extended ACL, it will filter things like the protocol, the source address, destination address, and port numbers. All of these will be considered, and based on all of these factors, it can be allowed or denied. So when it comes to the common errors that we may encounter with ACLs is that if we enter the AC is in the wrong order, for example, say for example, if we do a deny, say in this case, we have a deny statement first, that is denying anything, and then we have a permit for telnet. So here what would happen is, even if it is a packet for telnet, because it is any here, it will match with the deny and that will be denied. So the solution would be, we'll have to swap this around. That is, we'll have to first have the permit for telnet, and then we would have the deny for any. So telnet will be permitted and anything else will be denied. So the order is very much important, because the first match will be considered as the match. So even if you have an allow later on, a permit later on, that will not be considered if it is matches with a deny first. So in this case, we will swap the statements or reverse the order there. So for example, in this case, again, the problem here is, in here the statement 30 is allowing TCP traffic, but the problem is with TFTP, it uses UDP, not TCP. So if we use TCP here, it will not allow a UDP traffic. So what we will have to do is, we'll have to make it as a permit IP statement. So it will allow both TCP and UDP. So again, these are sort of the common errors that we may encounter with ACLs. One of the other common errors that we may have is, say in this example, what we have is 11.0 network can use telnet to connect to 30.0. So 11.0 can use telnet to connect to 30.0. But it is the port that we are using here it is put in the wrong order because we have the permit later and the deny first. So, so we'll have to match with the so we'll have to configure this accordingly as shown here. In this example, again, a similar issue. We want the rule for 10.12, but what we have configured is rather 30.12, but what we have configured is 30.1. So again, that should be corrected as such. Otherwise, it is going to match with the permit because we want to deny for that. But here we have configured it incorrectly. So it is matching with the permit. So we have to go and correct that. Whereas in this case, the issue is the direction where it is configured, whether it is configured in inbound or outbound. So it should be applied in outbound, but it was incorrectly applied in inbound. So we have to again go and check that and correct that accordingly. So, and in IPv6 again, one of the things that you can see here is particularly about the namings. We will normally use sort of meaningful names if possible. That is a no FTP to 11. So something like that is a bit more meaningful name there. Here again the problem was it was applied in the incorrect direction. So we have to change that as we need. So again here fairly similar errors, but here in this case we have the error for IPv6 though. So we have to change the order of the statements. We have to have them in the correct sequence of orders. Again, because rules are processed in that sequence of orders. In this case, the problem is particularly with IPv6 ACL. It is similar to an extended ACL. We have to apply it closer to the source. So in this case, we will have to apply it closer to the source rather than closer to the destination. So again, that is the issue here. So in summary, when we think about access control list, the reason why we use access control list is because the basic aspect of routing is only about routing packets, taking it from one network, forwarding it to another network, or this forwarding packets between networks. Whereas with access control list, what we can additionally have is have some further control in terms of which networks can access which other networks, which is allowed, which is not allowed. So we can have more control over the traffic. Some traffic can be blocked, some traffic can be allowed. So that is the basic idea that we will use when we are using ACLs. So we will configure ACLs on interfaces. We will configure ACLs based on the protocols and on different directions. So inbound and outbound traffic, we will have different ACLs. Then we will have ACLs for IPv4 and IPv6, and then we can have a number of different categories under that as well. Then when it comes to standard ACLs, we will have only rules based on the source IPv4 addresses, whereas with extended ACLs, we will also consider things like protocol type, source and destination addresses, and also source and destination ports, or any one of these combinations can be used in extended ACL. So comparatively, compared to standard ACL, extended ACL is much more useful because we can have a lot more fine-grained control there. And also with standard ACL, we will have to place it closer to the destination because we only know the source information. So we have to filter it out at the destination, otherwise it will block other parts of the network. Whereas with extended ACL, we can, because we know the destination as well, we can place it closer to the source. So we can alleviate sort of the stress on the network infrastructure as well by using extended ACL. We can use sort of typical commands such as access list and commands, access list commands to configure the access list. So the idea is we'll create a set of commands using an access list, and then we will associate that list to an interface with a particular direction. So we'll have a set of rules that is saying permit, deny, remark for comments, and then we will associate with the interface saying whether it is applied for inbound or outbound traffic. So with sort of typical configurations, we can use show commands and things like that to configure as well. From an IPv6 perspective, what we would have is only sort of named ACL, so there's no numbered ACLs here, and pretty much extended ACLs as well. But other than that, the configuration is fairly similar. The only difference is there's no standard or extended option. The only option is similar to the extended option. So that concludes our discussion about access control list. So this is one of the basic security mechanisms in a way, control mechanisms in a way that we can bring into our routers, into our routing environments. So this is sort of the first step that we will have in terms of building controls, such sort of security type controls in networking environments. There will be some activities, some examples that may be shared along with this on LMS, so refer to those as well, and hopefully those will help you get a better understanding, and refer to those resources to clarify any doubts that you may have. And as always, if you have any further doubts, you can always contact me and we can talk through any of those issues as well. So until next time, thank you for joining this time. See you and bye.